Yeah, good morning. We are from Vertextechnology. The project title name is called Edupad, uh, a tablet-based educational system for the improving adult and literature in rural India. In this project, this is mainly this project were students' learning pad, educational learning pad. So in this project, we used an ARM processor. It's an 32-bit processor. So we used 128 cross 64 graphical LCD. It's an graphical LCD display. So it should display the characters as well as the images, and the students is learning now, so that's way the teachers will send the SMS with a format of images that should be formatted, will be displayed on graphical LCD display. And at the same time, who will be displayed that images, then the latitude values and longitude values will be sent to the GPS module. The data will be sent to the acknowledgement. Whoever is sending, they will receive your data will successfully posted on that target board. So here we used one ARM processor. It's an 32-bit processor. So this is an glass epoxy board. So here first of all, we in block diagram session, this is a master microcontroller and then GPS module and one GSA modem. Here we used one 128 cross 64 graphical LCD display we used. So this graphical LCD, we have in two pages, one is CS1 and another one is CS2. This is called chip selection 1 and chip selection 2. So we have formatted an half of the session for the images and another half of the session for the latitude value and longitude value, and we are displaying the text to data also. So the basically we are going for the small and it should be an accurate results. Let us coming into the hardware session. For here we used 9 volts and 1 amp transformer we are used. So why we used means, so learning purpose we can use for the batteries, it's a rechargeable battery, but we are in a demonstration kit, we are going for the AC power supply. So here that whatever the power supply, first of all it should be connected with the 1N4007 diode, and after that we are using an 1000 microfarad by 25 volts electrolytic capacitor. Here we used an GPS module. Here we used an one LM7805 regulator. It's 5 volts regulator power supply. And here I am using an LM1117 and fixed 3.3 volts regulator we are using. And after that I am using one LED. That's an power supply LED I am using. And here I am using an ARM processor. It's an 32-bit processor having two port 0 and port 1. Total 64 pin IC, QDIP, quadrupole, dual in package line. So here the port 0 and port 1. Port 0 consists of port 0.02, port 0.31. Total 32 bit, and port 1.P1 having port 1.16 to port 1.31 having an 16 bit. So this processor will execute 16 bit architecture as well as 32 bit architecture. So having 16 plus 32, total 48 input output bidirectional, and the remaining 16 pins are somewhat reset, crystal, ISP and USB and battery for the real-time clock, and somewhat external we are going for the VCCs and grounds. So here we are having one is an ISP switch and another one is reset switch. ISP means when we want to dump the program onto the microcontroller, we need to press the ISP. Otherwise if we want to dump if we go for the execution mode, we want to press the reset button. And here that ISP is connected with P0.14th pin and the reset pin is connected with 57th pin, and here we are using an 12 MHz crystal and it is generated 1 microsecond delay to run the program in the internal CPU. Here those pins are connected with 61 and 62. This is the heart of the circuit for the microcontroller and crystal. Okay, so here I am using in max 232, and this is for we are taking the data from the satellite, or we are sending the data from the GSM. This is an max 232 IC, and this is an voltage level converter which will send to the microcontroller and mediator IC. Okay, so here this slot is called the 16 cross 2 LCD display. Whenever we will go for the 128 cross 64 graphical LCD, either we can use external LCD also. Why? Because in testing mode I used LCD. In the execution mode, that learning pad, now I am removing the LCD. So let us that we having a two UART options are there. One is UART 0 and another one is UART 1. UART 0, port 0.0 and port 0.1. This is connected with GSM module. Here the GSM is global system for mobile communication. The mainly this module will works under 800 MHz to 1800 MHz frequency. Such it will receives the data and sending the data. Having some command structure format is there. Those are the commands are called AT command structure format. So in AT command, so we are having around 4 to 5 commands are there. Those are the command called AT, that is called attention. AT plus EMGF, that is called text mode. Why we are going for these commands means, when the microcontroller will communicate the GSM, means first of all the GSM modem we have to configure. So whenever we have to configure, we need to connect the PC. So we are going in the execution mode, the microcontroller will communicate, those are the commands. So that's why these are the commands are inbuilt on the GSM modem. That AT plus CMGR, that is called received SMS, AT plus CMGS, that is called sending SMS, AT plus CMGD, that is called delete SMS. Why we are using these commands? So whenever the author or whenever the lecturer will send one image onto the education learning in this display unit, when the SMS is received from the lecturer, that SMS will be loaded onto the SIM card. Fully the SMS goes on increasing, the SMS can't receive. So such way we used AT plus CMGD. Whenever the SMS is received, we are displaying the data. At the same time, whatever the display data, they will send to the owner's mobile or lecturer. Your data will be posted onto that authorized exact position, and that whatever the received SMS, that should be deleted. So receiving, sending, deleting, we have a commands, those are predefined on the SIM 300 module. In this SIM 300 module, we have coming into the first power supply section, filter capacitor and 7805 regulator and LM1117 3.3 volts regulator, SIM 300 module, SIM slot. We can use networked SIM, which you are in a college, you can use your networked SIM, and this is an max 232 coming to the microcontroller, and SIM 300 is an mediator IC, and this is an antenna, 3 dB antenna, and here I am using an buzzer, means if the SIM card is properly inserted or not, we can make a call to that one. If call is perfectly ringing, so the modem is perfectly working. So here I am using a transistor for the LED. This LED is on and off with taking of some time, means it is fully perfectly worked. Otherwise it is continuously glowing that the SIM card is properly inserted, not inserted, and it is not connected to the networked area. So I am taking the call, please. Yes, so whenever we received like this type of beep sound, that is called, we are getting the signals from the authorized cellular network. So this is called in SIM 300 with 9600 baud rate. So this was perfectly working. So let us go for the GPS module, and this is connected with UART1. That UART1 having an port 0.8 and port 0.9, those are UART1. So here we are using an GPS module. So those are coming the signals from the satellite Rasta 634 or GPS module. We are using this GPS modules in a vehicles or theft conditions, or in a ship. We are going on the sea. We don't know how which direction we are going. We are moving. So we want to locate that executable positions. We need to track the data from the satellite. So that's way. So we in our project, why we use it means we are posting the images which the data will be posted. The person is staying which position. We want to get the data from the satellite means that's why we are using an GPS module. The data will be displayed on the pad. They will send the reverse acknowledgement. The data will be posted to the exact position of the latitude value and longitude value using an GPS module having 65 channel with 2 minutes of time. It will track the data. This LED will be glows whenever it is not tracking. We are inside. If you are going for outside, the red color LED will be on and off. We will get exact values from satellite. So here we are having components. Those are the components: bridge rectifier, filter capacitor, 7805 regulator. Here the green color LED is called as a power supply LED. We are using additional max 232 that we are sending the data to the master microcontroller and take any of this is having a max 232, and this is also having max 232, and this is also having max 232. Why we are all means those one kit having the master head will send the data and receive the data. Those are called level conversion circuits, and these are the called RS232 cables. Those are recommended standard 232 cables will send the data as well as receive the data. In that cable we have a 9-pin connector. In that 9-pin connector we have a second pin is called a receiver, third pin having transmitter, fifth pin is called ground. So total 9 pin. We are going for the only 3 pins. Remaining are handshaking signals. No need of remaining pins. Only we required receiving, sending, and we need ground. So ground means properly that the ground will be common ground, means which we are not connected to the common ground, we will not get the data from the satellite, or we are not connected to the GSM. Whenever we are not connected to the ground, we cannot get the data to our master microcontroller. We will go for the execution mode. So so in 128 cross 64 we are having total 20 pin. In that we have a first pin and here the 20th pin. In first pin I will explain 1 to 2 to 20. First pin is called ground, second pin is called VCC, third pin is called VEE, contrast adjustment, nothing but a brightness, and fourth pin is called register select, fifth pin is called read write. So we are sending the data to the master microcontroller to this one.